Okay, let's get started. Hi, everyone. Thanks for joining this session. I see some of you were here yesterday, so good to see you again. We did a similar session last night to talk about data scientist career guide. And tonight we're going to talk about data engineering. WeCloudData has just published a new data engineering career guide. I'm going to share the link with you. It has a lot of detail. I sort of briefly talked about it last night, um, but I'll discuss that in detail. Again, I don't have any formal presentation today. Let's keep it casual. Feel free to ask any questions you would like to ask regarding data engineering, career and job market. You can ask questions about data science as well. So let's get started. Oh, thank you. Looks like someone has read it already. Okay, so the data engineering career guide, we broke it down into 6 different articles. So the first one is just a quick introduction of data engineering, the current state of art. There are a lot of modern data engineering platforms and technologies. So we sort of start this career guide by discussing data engineering, what's involved, and then we move on to talk about data engineer. What does data engineer do? The similarities or differences between data engineer and data scientist or data analyst. And then we talk about career path, job market, the current job market demand. And then I think a lot of you will be interested in the learning path. Had a bit of details in terms of what you should be doing and learning. And also, depending on where you come from, if you come from non-tech background or if you come from IT, how you should prepare for data engineering career. And also a quick mention of portfolio project and how you should be preparing for that. Let's quickly move on to what is data engineering. So first of all, as you can see, the data engineering is trending really well. But if you look at the trend for data science, it's probably something like this, and there are definitely more buzz around data science. There are so many schools providing data scientists, training courses, but there are not a lot of data engineering courses, and it's usually very specialized. If a company wants to do NoSQL, then they will have to choose the technology platform first, right? Because it doesn't make sense for a company to use all 4 different types of NoSQL databases. They'll probably start with, Cassandra, DynamoDB if they use Amazon Web Services. A lot of companies will send their employees to Elasticsearch training, but that's usually when they have the need to deploy a project, right? And then they need people to be upskilled, or if companies are using Apache Spark, they might be sending their data engineers to the Spark Summit or whatever Databricks conference for some training workshops as well. But even though data, there are definitely more people searching about data science, data scientists. But if you look at the job market, I think right now, sometimes you might find more data engineering jobs out there than data science. As more and more companies move into the cloud, they're just sort of rethinking about the way they architect their data pipelines. They might be switching to different tools. So that creates a lot of demand for modern data engineers. A lot of the principles are still the same, but data engineers may find themselves like learning new tools, every few months, and there are always new exciting platforms and tools that are being developed. So what is data engineering? I broke it down by like I guess the data engineering life cycle, right? That it involves a little bit of data science as well. The way I look at it is that data engineers play, important roles in different parts of the, data science life cycle, right? Yesterday we talked about data scientists. Usually when company work on a data science project, there's a business problem, right? And then once you figure out what kind of business problem you're trying to solve, we start to talk about data. Do we have the data? Right. The first step is usually data collection, but data scientists are typically not going to collect data unless it's some sort of ad hoc analysis, collecting data from Twitter, doing some web scraping. But I think in production, most of the time, data collection or ingestion are tasks that are done by data engineers. And data collection means a lot of different things, right? Because if your data come from, databases, data collection means just building the connectors, right, to read data from databases. You'll be reading data from a relational database or NoSQL database like MongoDB, right? But sometimes data need to be collected from a SaaS platform, right? So if your company use MailChimp for marketing campaign, Salesforce, HubSpot for CRM, you probably want to bring those data into your data lake or data warehouse. So that means data engineers will be working with, connectors again, but those connectors are collecting data from a SaaS platform, right? Or reading data from APIs. And sometimes the data is just not available directly through an API. Then most likely you're going to be writing some code to collect data from the web, or JavaScript is involved, Google Tag Manager, so you will be collecting web analytics data directly into your data warehouse, for example, right? So it turns out that data engineers actually have to spend quite a bit of time and effort helping company figure out data collection. But if you join a team that has all of these built already, then most likely you're going to be working on data transformations, right? Doing data governance, quality control, and building new data pipelines. And for companies that build big data solutions, data collection also, I think sometimes data collection is closely tied to data ingestion, right? Because after you collect or extract data from the sources, you want to ingest the data somewhere. You have to store that, right? But that process is data ingestion. And there are a lot of things you need to take into consideration, such as how fast do you need the data to be ingested, right? Can you do this, on a, does this need to be real-time based, right? Are you pulling the data, or do you want the data to be pushed through some sort of webhook, right? Do you do this on a daily basis, on a weekly basis, on an hourly basis, or you want that to be just ingested as soon as possible, right? And all of these questions or right considerations will decide what type of tool that fits your need. And sometimes you have to think about the destination as well, and how scalable you want this to be, right? Because obviously building more scalable data ingestion solution will involve more containers, more EC2 instances, servers, and sometimes you will even need like Kubernetes, right? So that's data ingestion. So data engineering involves collecting data, ingesting data, and then of course, where do you ingest the data to? Well, some sort of data store. It could be databases, right? A relational database. It could be distributed systems such as Hadoop HDFS or AWS S3, that's object store, right? Or blob storage. So that's data storage. And when we talk about data storage, then you have to understand different types of formats. What is the most efficient way to store and organize your data in a data lake, right? Maybe Parquet is a good format if you're going to do a lot of analytics on the data, right? But sometimes, storing the data in a database makes more sense. And you probably need to understand row-oriented databases and column-oriented databases as well. Okay, so that's data storage. Now, when data gets stored somewhere, we need to start making sense of the data. But before data analytics professionals and data scientists start to analyze the data, well, the data usually will need to be prepared first, right? If we're just talking about one data source, that might be, relatively easy. But most of the real life systems, data systems will have all kinds of data sources, right? So you probably want to bring all of those data together. So that means data integration is required. You need to encrypt the data, right? If privacy is really important, you have to sort of be compliant. And And data will need to, some of the column need to be masked as well before you let anyone access the data, right? So you probably have different level of access, right? When data gets stored in data lake, those are raw data. You probably need a data engineer or whoever who has the privilege to mask the data, let's say the social insurance number, passport number, whatever data that you decide that you don't want your data analyst or any data scientist to see or business users to see, just to be to stay compliant. Now, in that case, you want to mask the data, right? There are different ways to do data masking. So, and encryption is, of course, also very important. And then we start to do data transformation, right? Selecting the data you need, doing data filtering, maybe for your data warehouse, they're data from certain parts of the country that you don't really care about. You may want to filter them out. And of course, you're going to merge, join the data, do aggregation. And all of these effort, right, are worth it because that helps you improve the data quality. And also it does a lot of the heavy lifting, data merging and aggregation. So that sort of abstract the business logic away, right, from the data scientists, so that when data scientists start to work with the data, they won't be seeing 4,000 different tables. They might be just dealing with 20 important tables that has been pre-processed. And those data are properly stored and modeled, right? And so their speed to insight will be a lot faster because they can write simple queries. They don't need to deal with all of those complex, business logics. And data engineers actually deal with a lot of business logic. They have to work with the business closely as well, because when data has some issue, they have to understand, well, how is this data ingested? And why are we seeing this kind of weird value or some sort of, inconsistencies in the data? And a lot of times it depends on the business side, because the business will be working with IT, software, application team, right, to design some features on their web application, and they decide to, okay, for this dropdown, let's just provide these 3 values, and everything else we'll just call them other, right? It may not make sense when it comes to data engineer. When data engineers start to analyze those data or transform those data, sometimes they just don't know, okay, what does other mean, right? And proper data dictionary is also necessary, and also metadata. So data engineering is very important because you don't want your data scientists to deal with all of these, right? It's not as glamorous as data science, because data scientists will be building machine learning models and presenting all the great work to the business side. But data engineer is absolutely crucial, because without this, this massive data transformation, effort, I don't think data science team will be able to do a good job, because they'll find themselves spending even more time just trying to figure out data, right? That's a very painful process. So the transformation part, traditionally, companies will apply something called ETL, which means data gets extracted first, and then they transform the data, and then they load the data somewhere into the warehouse or data lake, right? It's still very popular in the big data world. I think ETL also makes a lot of sense, but the transformation is quite expensive effort, right? A lot of companies will, like banks, insurance companies, they have specialized ETL tools and platforms, such as Informatica. It's like very good at doing this. You don't have to write a lot of code, and of course you can customize. But these expensive tools, it comes with it's not just the software license, right? It's dedicated servers that's just running ETL and data transformation. They can leverage the Spark engine backend as well, of course. That's why the world is so changing so quickly, and a lot of companies would prefer just to write their code and do version control instead of working with GUI-based tools. But anyways, that's data transformation and ETL, right? But as you can see, the transformation is a big effort, and it takes a lot of effort just to decide, okay, how are we going to transform the data? And you sort of need experienced data architect and data engineers to decide that, right? To work with the data scientist or an IT to decide that. And that is a huge effort. It may take weeks and months. right? To even build the data models and everything, data warehouse could even take years. ELT becomes popular in the past few years because it sort of switched the T and L, right? So which means we're still going to extract data first, and then we're going to load the data into the warehouse first, and then we do transformation. Now, the good thing about this approach is that the data gets ingested into or loaded into the data warehouse or whatever staging area first, right? So when data engineers or analytics engineers are trying to figure out all the data model and stuff, data analysts and scientists, if they have access to the data, they can already start writing queries to start to prepare the data. And so it's a lot faster in that way, right? And a lot of effort can happen in parallel. So yeah, that's ELT. We'll talk about that later in the learning path. So that's transformation, right? And then data engineering also involves building complex data pipelines and automating those data pipelines. What you're seeing here is some sort of data lineage, right, or data pipeline. And this is called a DAG, right, direct acyclic graph, and from Apache Airflow, which is one of the most popular pipelining tool. As you can see here in this diagram, this is the starting point, right? And then you're going to kick off a bunch of processes, right, to process the data or maybe extracting data. But these jobs have dependencies. So for example, this box here, this step here, right, leads to a bunch of other processes, right? So if this step failed, then it doesn't make sense for you to continue other parts of the pipeline. So you have to fix that first, right? So maybe the data engineers or the data engineering team will get notified if something failed. Because if you keep running your pipeline with incomplete data, the output is going to be garbage, and it may waste compute resource. If we're talking about big data, terabytes of data, that might be, the cost is pretty high, right? So you want to pause here and then fix the problem and then continue, right? And sometimes after you finish all the pipeline, you notice that, okay, we made some mistake or the data is not correct. So you want to come back and rerun the whole thing. Or you may want to just backfill and just rerun the whole thing pipeline for the past 30 days, because every day you would like to create some sort of table and snapshot. You want to redo that 30 times. Imagine you need to do this manually. It's crazy, right? So with this kind of orchestration tool, you can manage things, easily. And I wouldn't say it's easy, but you can definitely sleep better at night as a data engineer, right? Pretty powerful stuff. There are also new tools other than Apache Airflow, such as Dagster, Prefect. So this data pipelining field is also growing quickly. All right. And then, of course, data quality and governance. I think when you work in a larger team, you're always going to have that need for controlling data quality, because the data now is not just controlled and used by a single data scientist who's doing everything. It will be shared across different teams. There will be different data scientists from different departments accessing the same data set, similar tables, and you want to make sure that the data quality is good, it's consistent, right? Governance also involves, people, process, and technology. So data quality is part of data governance, actually. So you definitely want to prevent garbage in, garbage out situations, right? So we'll touch on data governance a little bit later. So that's data engineering. This is the whole process. We start to see the convergence of different engineering disciplines, right? And data engineer share a common set of tools, right, and skill sets with data scientists, software engineering, and also DevOps engineering. So yeah, I think the second half of this article is basically talking about different types of data engineering initiatives or type of projects, right? So we have traditional data engineering, which involves, ETL, SQL, big data, and there's also the modern data engineering, right? Where we talk about modern data stack. I think I mentioned this a lot recently, but it's pretty exciting. So that's, the modern data stack follows the ELT approach, right? So if you look at some of the tools in the stack, from data ingestion perspective, we can use, Fivetran, Apache Airbyte, ELT, using DBT and Snowflake. Now, DBT is kind of similar to Airflow, but it's used for SQL, but it can do so much more, right? But it can't really be used to replace Python, of course, at least as of yet. But you can use it to to simplify a lot of the SQL-based ELT or ETL workflow, which is pretty powerful. And it works, goes really well with a modern data warehouse such as Snowflake or Redshift and Google BigQuery. And then reverse ETL means sending data back, right, to where they come from. Let's say you have some data coming from MailChimp, from HubSpot. These are CRM and marketing data. And after the data got ingested, right, into your data lake, and then we use SQL and DBT to do some sort of transformations to generate, to distill the information and generate more insight, right? Let's say we build a customer profile and we would like to, integrate data from different sources, right? So we know more about each customer. And now you would like to send the data back to the CRM system. So your sales team now have more information about these customers or potential customers, right? And that is the reverse ETL. And it turns out that it's not, company has been doing this for many, many years, but recently we start to see some projects such as High Touch that just help companies, manage the reverse ETL process in a very, nice way, so that it saves a lot of data engineering effort as well. Otherwise, the data engineers might need to maintain a lot of the, the API to deal with a lot of the APIs, which is not fun, right? So these tools help us automate as much as possible. So in the modern data engineering world, there's the modern data stack. Right? It's typically the analytics engineer or analytics data engineer who's working on this. But there's also the big data stuff, right? So that's, data lake and data lakehouse. So these are companies that ingest massive amounts of data. And data lake is probably a better place to store those data, because data warehouse is still quite expensive, even though storage and compute can be separated, right? But when you have really massive amounts of data, it probably makes more sense to ingest the data into the data lake. But data lake didn't really deliver the promise, right? So Hadoop, Spark, it didn't really deliver the promise, of data lake. And data lakehouse is sort of an improvement on that, right? To introduce, ACID to the data lake, so that now you can do not only batch processing, you can do, real data, so real-time data analysis on data lake, and also change data capture is very important. So whenever the source data changes, you would like to push that to your lakehouse. And there are a couple of options in the market, such as Apache Iceberg, right? Apache Hudi, which is used a lot at Uber, and Databricks, and also has the Delta Lake. So these are some of the really good options. It's getting pretty hot in the past few years. And in modern data engineering, serverless is also a very popular topic. We start to see more and more companies starting to deploy some sort of serverless data transformation process pipelines, and we use that internally a lot as well for very different kind of tasks. And definitely something worth looking into. I've seen some articles discussing like how the companies like does the entire data engineering pipelines using serverless. But when I look at the diagram, I feel like it's a bit overwhelming, because I think to build it, it's cool. To maintain it, it's kind of hard, to be honest. But it's definitely something that's getting popular as well. All right. So this is a quick introduction to data engineering. Now, what is a data engineer? So data engineer sort of does data engineering work, right? So in this article, I follow the same structure. So we'll talk about data collection, but I tend to focus more on what the data engineer would do, right, in data collection process. And then data ingestion, data storage. This is where I talk more about more different kind of tools, transformation, pipeline automation. Yeah. And also we compare data engineer to data scientists, software engineers, and also DevOps engineers. We sometimes get questions from our students saying that, well, what is the difference? I'm so confused about these kind of different kind of data jobs. So this section, I think, explains that pretty well. So give it a read. It's quite long. Yeah, so that's data engineer, and we also sort of describe what a typical day would look like. But this is just for one type of data engineer that's working on maybe serverless data ingestion. But just keep in mind that there are different types of data engineers, right? There are people who focus on ETL, ELT. So if you work on this, then I think understanding the entire data ingestion collection pipeline is important, and you will be doing a lot of transformation. Whether you do that in the in the ETL approach or ELT approach. There's the big data and BI engineer. They will, I think you need to be familiar with Apache Spark. Doing some sort of heavy lifting data processing or batch data processing. And sometimes you have to do real-time data processing as well. If your company work with Spark streaming or as long as the company ingests data in real time, I think there's a need for real-time analytics. And there's also the data savvy software engineer. These are software engineers who build data intensive applications. So they will be dealing with streaming systems such as Apache Kafka or Amazon Kinesis. They will ingest the data into distributed messaging queues, and then you can use Spark streaming to analyze the data in real time or using Apache Flink, right? Some data engineers work like ML engineer. It really depends on the team culture because the company may have a data science team, and then the data scientists sometimes rely on the data engineers to write ML pipelines, and that's sort of like ML engineer. I guess the title itself doesn't really define you, right? So it's the work you do that defines your job. So I found that sometimes the titles are pretty confusing. It's the data engineers working on ML engineering. But it's also probably because this field is evolving. So I think the title sometimes doesn't really matter. Okay, so that's this page explains the data engineer. And then we talk about career path. I'll just mention this briefly. You can go down the more technical path, right, to become a senior, lead, or staff data engineer. The compensation will be amazing, I think. But if you're interested, definitely you can go down, the traditional managerial route. Or I've seen data engineers switch into data analytics and data science, switch to software engineering. And interestingly, in this field, because there's so many new tools and platforms that got open sourced, every year, and there are companies or startups that built their core based on open source, right? And then you need tech evangelist or tech developer advocate to do a lot of presentations to work with the community to grow the open source project and also your company's product. A lot of them come from a very technical background, and then they sometimes are involved in training their clients as well. And this could be a very interesting role if you love public speaking and working with people in the community. I think it's a cool job as well. And of course, there are a lot of consulting opportunities in data engineering as well. Okay, and then the job market right now I think looks great for data engineers because I think definitely the demand is very high and the supply is relatively lower compared to data science. right? So I think if you have the right skills, you understand how to work with different tools, and you have worked on some projects, you can definitely get a data engineer job. Just a quick search on LinkedIn shows, tens of thousands of results. I don't think this is that accurate, because sometimes I see like data scientist title, but it tells you the relative scale. Because if you search the same, like if you search for data scientist, you might see like 15,000. So there are more data engineer jobs out there sometimes, not always. And that is sort of in line with the data we collected from Indeed, right? You can see that there are actually more data analyst job, followed by data engineer, data scientist. But sometimes you'll see more data scientist jobs than data engineer. So it's kind of fluctuates, which is totally fine. But as you can see, it has really strong demand in the job market. And we also have some insights regarding how the data is distributed among different states and cities in the US and in Canada. I think this is pretty straightforward. I'll leave it to you to read. Another interesting insight is that data engineering jobs require more experience. So most of the job postings will mention things like 3 years of experience or 5+ years of experience. And ideally, companies are looking for people who actually have built something in the past, right? Because they understand that it's kind of hard for you to, if you haven't worked in this industry long enough, you probably haven't really got exposed to many different types of data engineering challenges, or haven't really got an opportunity to work many different sets of tools. Because if you join a company working as a data engineer for, let's say, 1 or 2 years, your company can only use so many tools. And right, so if you use DynamoDB as a NoSQL, then you're much less likely to be working with MongoDB, Elasticsearch. And you probably have to gain that kind of experience in a different job. And that's probably why companies always prefer people who have more years of experience, and they have solved a lot of, because when you start to build data engineering pipelines, right, or help the company build data infrastructure, there are a lot of decisions that needs to be made, right? Choosing the right tools, choosing the right platform, and how you architect your data pipelines and infrastructure. You can engineer this in many different ways, but the cost of experimentation is too high. You can't say that, well, today let's try AWS doing everything using managed services such as EMR, AWS Glue, DynamoDB, Kinesis, right? And then it turns out that, well, it's too expensive, right? Or it doesn't meet your requirement. Well, let's try a different approach. Well, that's a really huge waste of time and effort and money as well. When it comes to data science, I think the experimentation cost is relatively lower because, you can try deploy different models. You can do A/B testing. Well, A/B testing on the infrastructure side is going to be quite expensive. So having experience is definitely useful and important for data engineers. And in terms of salary, I think, well, you can read this. People will have different interpretation. It also depends on whether you're going to go for a big tech company or you're going to go work for a bank, right? This is the number that we pull from Glassdoor. You can always find the most current data from Glassdoor. But overall, like if you look at the average, this is a very decent number. So senior data engineer is 150, and on the high end, 190, right? But keep in mind that this is not the total compensation you would get at companies like Facebook and Google, because most of the banks, insurance company, they just don't compensate people that way. So I'm assuming that majority of the salaries reported on Glassdoor might just be a regular data engineer job. From that perspective, it's pretty decent. I understand that if a new grad got hired into Facebook, the total compensation could be 160, 180. But when you look at the market as a whole, 150 is really decent number, right? Especially for career switchers, I think. So that's the job market. And then I think we spend quite a bit of effort on creating the learning path. This is the skill set requirement by the job market. Python is very popular for even for data engineering. SQL, Spark, AWS, Hadoop, and then you start to see things like Java, Azure, because I think when you go work for a bank, they use Java a lot, or Scala, right? So you see Scala there as well. Yeah, but these are some of the key skills, like I think the most fundamental skills you need to have. But depending on the companies and industries, they tend to go with different cloud platform and different tools. So you in this, like, I think for data scientists, if you look at this type of plot, you probably just need to focus on the top 5, right? With data engineering, I think only knowing Python SQL is probably not enough. You need to pay attention to the things that are in the long tail, because when company need it, even though it's not something that every company need, but that means it's pretty important for this company. So there are a lot of different tools. But I think understanding the principle and the fundamental skills are definitely important. And I think as a data engineer, you just need to be able to adapt and learn things really quickly. It's impossible for you to learn all of these tools, right? This is the curriculum that we open source. You can look at it, right, and follow this to learn data engineering. So you need to pick up programming for sure. Linux is very important, I think. You don't need to be a Linux, expert, but just get familiar with command line, because you'll be running Python script, sometimes cron jobs, writing Lambda functions, and run that from the command line to work with the CLI or Docker containers. So there are lots of opportunities for you to work with a Linux command line. So you definitely need to be good at it. And then SQL, Python, right? Scala is optional. If you come from computer science, Java background, then definitely pick up Scala. But if you're just switching career to data engineering, I wouldn't worry too much about it. You might be not qualified for some of the data engineering jobs, but as you can see, if you look at the trend, as long as you're good with Python, I think you'll get data engineer jobs, but not those hardcore Scala. And if you want to work as a data engineer at Twitter, well, everything they do, they use Scala. So then you have to use it to know it, right? But I think for most of the jobs, SQL and Python are still more popular. You need to understand cloud. I would suggest at least, learn AWS or Azure, GCP. It doesn't matter. Just pick one of them. And I think the knowledge is pretty transferable. If you know AWS, then pretty much know how it works, right? And then you can pick up Google Cloud or Azure pretty easily. And databases and data warehouse is something we recommend students learn first. Because after you've learned SQL, I think it's very important for you to because in practice, I think most of the data come from relational databases, right? Even though more data got generated, right, in an unstructured way, but still most of the business use cases, we deal with structured data, right? And that's one of the reasons why the modern data stack or whatever, Snowflake, became popular, because it's mainly dealing with structured data. It can be used to work with unstructured data, but it's just not something it's really good at, right? So yeah, so this is where if someone come from IT or database background, and or data analytics background, and you want to become a data engineer, I would recommend you maybe start from a data warehouse or modern data warehouse first, so you can learn DBT, Snowflake, right? Dimensional modeling, building white tables. These will be very helpful, because you won't feel such a steep learning curve, and it's relatively easier for you to transition to analytics engineering before you go into the big data engineering, right? But those are data engineering jobs as well, from my perspective. And then once you pick up, data warehouse, dimensional modeling, and DBT, I think it's time to move on to the ETL world, right? where you have to do heavy lifting data processing, so big data, right? Understanding Hadoop MapReduce is still useful. I wouldn't emphasize too much on it, right? You definitely focus on Apache Spark, whether it's EMR or Databricks platform, and then learn one of the NoSQL tools, such as DynamoDB from AWS, or Cassandra, which is kind of similar, or Elasticsearch. A lot of companies work with Elasticsearch, right? Yeah, so that's big data. And then ETL and ELT is something, well, this is a typo, but it's something you can actually learn separately, because data warehouse is a very specific technology, right? And you can do all the transformations in warehouse directly. But ETL, ELT sometimes also is related to data integration, right? And ingestion, because data is moving around, like the data movement, right? Data being collected from the source and ingested into the warehouse data lake. And then you have data from 50 different sources, and you want to do data integration. You write a lot of Spark jobs, and sometimes data come in real time. So these are ELT, ETL related, and sometimes it involves real-time data processing. So that's ETL, and then you can move on to data lakehouse, which is a more advanced topic compared to data lake and big data. But this is where you get exposed to things like Apache Kafka, distributed messaging queues, and the lakehouse architecture. In WeCloudData's program, we cover Apache Hudi. We started to explore Iceberg as well. And you just need to learn, I guess, one of these. If you have this kind of experience, it can definitely help you stand out. But of course, this takes a lot of effort to learn. Not every job requires this kind of skills. Because a lot of companies, they probably just need people who's really good with SQL, understand data, the modern data stack. So that's relatively easier to learn, I would say. Yeah, so that's data lakehouse. And then, and of course, to automate the entire pipeline, right? Then you need to learn Apache Airflow or Daxters, but these are similar tools. You just need to learn one of them. Data build tool is something I highly recommend if you want to become analytics engineer. And there's also some other concepts, right? That are also related to data engineering, such as testing, unit testing, CI/CD. Sometimes you need to work with Docker containers, especially when data engineers are asked to do some sort of benchmarking, helping companies to pick different kind of tools to work with, and you have to do experimentation. So knowing how to work with Docker containers will be helpful. Data governance is an important concept you need to know. It's more about the people and process, right? But of course, there are tools such as Amundsen for data cataloging, but I don't think these are very hard to learn. But understanding and appreciating, I think the importance of data governance is definitely helpful. And you'll actually probably need to work in an actual data engineering team and a data company or whatever to understand how this works. Because most of the company will have some sort of process in place, probably not the best practice. And sometimes it takes a lot of presentation and just convincing people, because a lot of people are just not incentivized to follow the best practices, right? They just want something to done fast. Yeah. So this is the curriculum, and in this guide, we spend quite a bit of effort just explaining what each one of these are, like SQL, Python, the things you need to learn, Linux, AWS services that we recommend, the tools that are related to data engineering, and then specialization, right? So we talked about analytics engineering, the modern data stack. So under analytics engineering, so you need to understand databases, right? And data warehouse, understand how to work with different data connectors to ingest data, ELT with DBT, and data modeling as well. Okay, for big data engineering, Spark is something you definitely need to learn. So try to understand distributed system, how data lake works, right? And when it comes to data lake, the technology itself is pretty mature. So a lot of times I think it's just more about following the best practices, right? For example, what should be the data staging strategy, right? So I think in majority of the courses, people don't really talk about this, right? But this is very practical. Yeah, it's quite straightforward to learn how to just call like a command line and move data from A to B. But in practice, there are a lot of other considerations, right? What is the staging environment? How do you even structure the folders and buckets in AWS, right? How do we protect the data? So these are the things that you actually have to work on it in order to understand what is the best practice, because every little thing here is like a bunch of research and a bunch of tools, and you sort of have to try it to know which one is better, or unless you're working with someone who's more experienced, right? And there are methodologies that are outdated, right? And so if you Google around, sometimes you're following the wrong path. And that's what makes data engineering challenging, but also making it more very exciting, because I feel like when you learn a lot of the new technologies, you don't care about the very old technologies anymore, because you're probably never going to work with some of those legacy systems unless your company has a lot of legacy systems. But if you go work for startups, you're just like always using the new tools. But I think every day we're creating legacy systems. Anyways, yeah. So in big data engineering, Apache Spark is something I think a tool that we definitely need to familiarize ourselves with, and see if we can get more, even dive deeper into Spark internals, understand how to optimize Spark jobs. But I think the Spark ecosystem has become really, really solid and mature. So it does a lot of the optimizations on its own. But sometimes it comes up, this kind of interview questions come up, like how to tune your jobs, make it run faster. Because when you probably wouldn't feel it if you're just dealing with like 50 gig of data, right? But if you're dealing with hundreds of terabytes of data on a daily basis, every single script you write, if it's more efficient, it saves the company cost. And we're talking about hundreds of thousands, millions of dollar cost saving, and even more, right? And just like the GPU training, right? If you have a GPU cluster, would you use that for data transformation? Most of the data transformation or data preparation is CPU bound, right? So you don't really need GPUs to do a lot of those. But if you want to train your networks, then yes, you need GPU. So, and that's why sometimes you want to modularize it and try to use different types of infrastructure for different purposes. Data transformations can be done on a CPU-based Spark cluster, right? But if you want to build deep learning models later, you can use a GPU cluster. And Kubernetes works great for that purpose, right? And containerization and orchestration becomes important. Okay. And then streaming data. When you work on big data problems, a lot of times you want to ingest lots of data in real time, and you want to take advantage of the real-time streaming data, and Spark Streaming and Flink are some of the best frameworks for that. And Data Lakehouse, I think I briefly touched on that already. Highly recommend you read this Uber blog about how their data infrastructure evolved over the years. I think this is from 2017 to present. It must be old. They're building something new, but I think they already talked about Apache Hudi at that point, right? Yeah, and then data integration and pipelines. I think this follows the same structure, right? As the data engineer intro. I'd really just break it down and to talk more about the tools you need to focus on when you start to learn data engineering. Okay. And lastly, we have the portfolio project building. I think the typical mistakes people make on their data engineering resume is that, well, they put so many tools. And I've seen like a resume that has like, I guess there are like 50 different keywords. That's very overwhelming. I feel like this person knows so much. But when you look at the experience, the past experience is not even data engineering related. So that means he learned a bunch of tools, but he has never applied it, right? So to stand out, right, or to make your experience more convincing, I think you need to build projects. Now, the good thing about data engineering project is that it usually comes with some sort of, data system design, right? Architecture, building the pipeline that involves data diagramming, and you can always show that to people, right? And just walk them through how you built your pipeline, and make sure you understand each box or on your diagram really, really well. And of course, deploy your pipelines and upload your code to GitHub. That would be very useful as well. Okay, so I have some examples here. Sample architecture, pipeline architecture, some sample projects, presentation done by the student in the past. So go check it out. I have some sample YouTube videos as well. You can go to YouTube/@WeCloudData, and you should be able to find our student project presentation as well. I actually have the link here. I'm going to share with you. All right. I think that's pretty much it. I just went through the career guide, and it's a lot of stuff. I highly recommend you read it yourself. It's going to take me hours if I'm going to go through that line by line. So I hope you find this career guide useful, and you can use it as an actual guide if you would like to start learning data engineering. So I think I have some more time for you to ask questions, so feel free. Again, this is very casual. You can ask any kind of questions you would like to ask, and I'll be around to try my best. I don't think I have answers, to everything, the best answer for every question, but I'll try my best. There was one question: is Alteryx also considered a data transformation tool? Yeah, I think it was pretty popular in some of the banks, right? Large companies. I think it's one of those tools data engineers and scientists can use. Some companies believe in this kind of tools, but I can tell you that many companies don't use it because the data infrastructure can evolve really fast. When companies move to, first of all, if it's a startup, they're less likely to use it. They either don't have the budget, or they want to keep everything flexible, because things can change really quickly. So they would probably prefer to work with open source tools, right? In that case, but of course, you need to have like data engineer who actually has the experience, right? From a data ingestion perspective, I would say the reason why modern data stack becomes so popular is because at the beginning of a company, like a startup's, data journey, right? They're always making this decision, like, should we hire a data engineer to write all the custom code, or do we just pay, let's say, $5,000, right? A bunch of connectors, and then, you just need one person to take care of it, and you can, within 3 days, you can start ingesting all of your data, right, into a data warehouse, let's say Snowflake. And then your data analyst can start analyzing data right away. That's very appealing to many companies. So there are a lot of the startups, they prefer it this way because it's just so much easier to get started. But over time, I think their data infrastructure will get more sophisticated for sure. Tools like Alteryx, there's a cost associated with it. It's not cheap. So I think usually intermediate sized to big companies may be interested in working with this kind of tools. But I can tell you that a lot of serious data engineers probably don't like to work with this kind of tools because they feel somewhat limited by it, right? And when your data system become more, unless this is a tool that can solve all of their problems, unfortunately, it's impossible, right? When you start to realize that parts of the pipelines, you're writing code, you can do version control, do auto unit testing, and then part of the pipeline, you have to use a GUI-based tool. It's not a good, experience. But you know what? In real life, nothing is going to be perfect. Companies will add tools, remove tools over time. You just got to live with it. And that's why I think data engineering sometimes is a little bit hard to be automated, because you're always making changes. You're changing tools, and you have to do a bunch of migration. And I think this is the messy part of data engineering, and it's a little bit harder to be automated. And also, like, people who initially built something up and will leave the company, and it just become a bunch of legacy system. It's not well documented, and new guy coming in is just like frustrated. This happens a lot. Just be prepared. Working as data engineer sometimes could be the data is not going to be always be clean. It's always messy, right? But you're actually generating a lot of value for the business, because there's no quick fix for this. Your VP of technology changed. That changed the entire relationship with vendors, and the new VP may bring in different vendors. So yeah, you just deal with it, and it keeps changing. It depends on the company engineering culture as well, right? From Chris, I'm learning full stack development. Which data path is the best complement for AI application deployment? Um, if you're learning full stack and you want to work with AI tools, I would probably recommend machine learning engineering, because I guess your goal is um, to be able to deploy, like, or bring AI capability into your web application. In that case, I think you need to be very comfortable working with, like, REST APIs. You understand how to either deploy models yourself, or maybe just leverage, um, models like, ChatGPT, right? And they have an API, you sort of integrate that, but you need to have that ability to build some sort of interactive chatbot. That's what you will learn in full stack, I think. But it's not so much data engineering related. I think, and of course, ML engineering, data engineering is important for ML engineering as well. But if you come from full stack, unless you really want to switch to data engineering, because I think I mentioned that in the career guide, working as a data engineer, you don't really get to build a lot of the, you know, you don't build web applications. So it's the data application and system that you're working with. And a lot of times it's a bunch of code, and you always have to check the quality of the data, but you don't get to see the product you build a lot of times. It's not like you don't have a UI, for example. Um, yeah. But I would say data science and machine learning engineer is probably the better path to go down if you come from a full stack background, or if you would like to build AI application. Definitely data science and machine learning engineering. Yeah, not data engineering. And you're doing a lot of scripting in data engineering, um, not like building software. It's kind of different. Yeah. What is the career trajectory for a successful data engineer versus data scientist? Yeah, I think I touched on this in what is data engineer and also what is data scientist. You can refer to the data scientist career guide. I think it's kind of similar. So, oh, career path. It's in career path. So you can go down the technical path, right? Become a senior, lead, and staff data engineer. But same applies to data scientists. And some data scientists will want to switch to machine learning engineering because it's more engineering focused, right? So data scientists will do experimentation, build a lot of models. But to deploy the model, you probably need to rely on the machine learning engineer and ML ops. So sometimes data scientists will find that, well, you know what, I'm actually more interested in the deployment side. So they're actually building the data product. So they would like to invest time in learning machine learning engineering. Yeah, for data engineer, I think I see a lot of them switching to software engineering, because I mentioned that there's one type of data engineer that's like people who actually are a software engineer and they're building data intensive applications, right? But they're not really building AI applications. Data intensive meaning your data comes in real time in large volume, and you would like to, process those data in real time, right? Or help your company to scale their back-end data systems. And that's definitely a combination of data engineering and software engineering. Okay. And then of course you can become an engineering manager, and yeah, software engineer, in consulting as well. There are a ton of consulting opportunities in data engineering right now, and cloud as well. No problem. Any other questions? There's a question regarding security. How much should data engineers be concerned with security? I think when you do data ingestion, encryption is important. It's more about, first of all, I think data engineers will need to understand who can access what, right? But the cloud engineers are involved in this, right, to make a decision. But I think data engineers will decide how to ingest the data and also how to encrypt the data. But I think the good thing is that most of the modern tools that will help you encrypt the data, or you can write some hash function yourself. And data engineers will need to work with the business to decide what are some of the sensitive data, right? And they want to mask those data in a data lake or in data warehouses. And some database will have this kind of masking capability by default, right? So these are the things, I think data engineers will need to be concerned about. But definitely not the networking security stuff. That's, not what data engineers should be worried about. Yeah, and sometimes when you work on projects, access control is pretty tricky. I don't think it's the data engineer's job, but it could be DevOps or IT. But basically, if you're involved in multiple data projects, and sometimes two projects will have similar or same data input or data sources, right? You want one of the consultants to access some tables, but not other tables. And you may want to have like role level access control as well. So it could be tricky, but I don't think the data engineer will need to worry too much about it. And it's usually at the beginning of the project, you have to define this really well, just to protect your company's data, right? How would a data scientist define their work as adding value to the business? It can be hard to articulate and convince upper management who only cares about the results. Any tips on how to better sell your work and strike a balance? That's a really good question. Yeah, I think unfortunately, not everything data scientists do will create new value, right? Because sometimes the model just doesn't work out. I think, first of all, I think documentation is important, right? Uh, Even if something doesn't work out, you need to document the process. And when something didn't work out or failed, it doesn't mean it doesn't have value, because it's good experience learned. And next time you can avoid this. And that will also help companies save time because you're probably going to work on similar problem in the future, right? Um, and in terms of like adding value, you really have to think about what is the outcome and result, right? The business management may always be concerned about like the dollar value, right? Or if they want to, you know, improve the results of, let's say, customer churn. I think data scientists will first need to be able to back themselves up, right? You need to let your management know that you are following a very good approach, right? So you have to basically find proof to back yourself up. But at the meantime, see if you can do you know, testing, right? A/B, that's why A/B testing is important, because whatever you've done, you're doing testing. And I think the team will probably need to have some sort of culture to understand that doing testing is part of the learning process. And that's absolutely important. Like you did something, you learn from it, it didn't work out, it's totally normal. But if you happen to be dealing with like executives that don't really understand it, then you need to be smarter. Like for example, a lot of time it's not just about the models. You need to understand, now you need to understand the business process. You need to understand how data is generated. You need to understand what are some of the things people do on the business side, because I used to work for a company that the company is going downhill, and we're building churn models. But honestly, if the company cannot fix the product problem and your product is not popular anymore, whatever machine learning models you build, you know, it will give you some lift. It doesn't change the result. It doesn't change the fact the company is going down, right? So sometimes like doing dashboarding and even just general analytics, like, and a lot of times you don't need models. Like, you know, you can always prove that your model is following a very sound approach, right? You have before and after, you have model validation, you have testing data set, at least prove that your model is making sense, but the result is not good, right? But can you do some other type of analysis to show people like what the real problem is, right? And sometimes just looking at those macro level numbers, you know, you can help the business understand what is the real pain point, and also learn how to set expectations at the very beginning of the project. Like, don't overpromise that your model is always going to work, you know, wonders. Most of the time, it's not, right? So I think any data team will need some sort of like, you know, the chief data officer or whatever, like needs to be, I think the communication skill, and also and a sales, you know, skill set is very important. Like you need to be able to influence people and help them understand, and you need to be able to explain things to people in a very layman's term as well. Yeah, yeah, sometimes executives are hard to deal with. Like, yeah, it's just tough. Any tips for data culture at a company that doesn't have a set of department for data analytics? Um, right. So you're saying that your company doesn't have a data team? Yeah. So, yeah. So I, so building that culture is important, and you should probably worry less about data science and machine learning. I think when a company, if the business has been around for a while, I think everyone in the company is hungry for data. They just don't fully realize the potential yet, right? Because in the past, data infrastructure is not in place. There's no data scientist helping them out. So you need to be the person who's actually, you need to socialize a bit. You're doing, sometimes like you're not asked to do things, but you can actually go talk to different people and see what their needs are. um, you might be spending a little bit more time just going out of your comfort zone just to build things for people. And a lot of times it could be just business intelligence and data insight, right? You want to be that helpful person, and then very soon you realize that you are the popular guy and people are all coming to you asking questions. um, and then, yeah, and it's important to work at the executive level, right, to help them understand the import. Like you need to advocate for it, right? So build small use cases to make sure that you can build some successful small use cases, building your first dashboard, or, and make sure you get an opportunity to present, at the company meeting, right? You really need the big boss to get the buy-in from the big boss, right, and get people excited about it. And then very soon you'll realize that people will start to appreciate it, right? And you become popular in the company. And that's the point where you realize that, hey, people actually start to think more about data, right? They start to ask you more questions. And that's a great opportunity for you to train people and just educate them. Um, don't jump into data science right away unless that's just an inevitable use case you have to do. Always start from business intelligence and data analytics, right? Um, and 6 months, 12 months later, you realize that, well, people now start to benefit from all of the data analytics work you've done. And then they start to ask more intelligent questions, because in the past, maybe they come to you, they have no clue what they're asking about. But now that you have deployed dashboards for them, it takes a little bit of patience as well. And you'll start to realize that people are starting to ask smarter questions. That's a good sign. And then at the same time, you have to convince your boss to invest in data engineering and just getting the data ready for more advanced analytics, right? At that point, there's no stop. People always want more information, better insight. Um, and that's probably a good start, I would say. Yeah. Yeah. You need to give people candies, right? And yeah, before you start to build something that's more influential for the company, and you may end up becoming a leader in the data team. Yeah. So sometimes working for small companies, I think it's actually good. I think having experience in big tech is definitely good for your growth. But working for smaller companies, like your work is more influential and you're more likely to get promoted, right? It all depends on how you look at this. Like, how do you define your growth? Is it, um, going from level 1 to level 4 at Google, or is it, actually building something that's more influential even for a much smaller company? Um, yeah. Um, Missed yesterday's data science career guide job market session. When will be the next session? The next session might be a few weeks away, I think. Yeah. But the recording will be available. So let me share the link with you guys. Join the Discord channel, and you should be able to. I think once the videos got posted on YouTube, in Discord channel, there will be like a notification, so you will be able to find it. Yeah, or you can just go follow us on YouTube. It should be under WeCloudOpen. There should be an event section. Yeah. Would you say the barrier to entry for joining a boutique data science consulting company is quite high? Um, I actually don't think so. Um, you have to be extremely, like you need to be able to adapt to things really quickly. I think working for a boutique consulting company, if you're only strong technically, that's not enough. Because most of the time like your project team will work closely with the client, and they have to basically have to socialize and communicate. Let's say, Students in our boot camp were involved in one of the project for a big company in the US. We sort of built the data warehouse for them on Azure. But at the very beginning, it's all about like we spent 1 month just talking to different departments in that company, just trying to understand like sales, marketing, IT, like just how they use their data and how like understand the business processes, to understand like how data is generated, because the business is quite complex. And when we look at the 4,000 table, like you really have no clue how to get started. Right. And there's finance data as well. Like we're not really specialized in finance. So you have to talk to people, and you even need to be able to get these busy people on a call, but there are 8 different departments, right? That took us a month. And I think data architect usually will play an important role in this, because they sort of need to be able to communicate at the IT level, working with the IT director and understand a different system access, understand like you have to do data profiling, right? And you have to sort of gradually generate value as well. Like, when we look at their data, I know it's quite messy. It's always going to be the case, but people just don't realize how bad it is, right? And you have to do data profiling and show them, right? And when you start to do data, like data ingestion part is relatively easy because we use Azure Data Factory. But when you start to transform the data, like in one of the tables, let's say they have 50 columns, and then when you look at those columns, you have no clue why some column, like, the field has missing. Like, why is it missing, right? Is it because it's data input issue? And so it requires a lot of communication. And I think one example is we realize that somehow, right? Just for an example, let's say before August 2021, right? The data looked very different from the data collected afterwards. And it turns out that they made some IT like changes on the IT side. They hired contractors to help them do a massive data cleaning work. And when we start to work on it, I have no idea that they did that. And people will not be telling you that at the very beginning. And a lot of times it's just like you have to be very detail oriented. You have to run a lot of queries. You need to be able to find problems in the data. And they have to be like, take the initiative and be proactive. They have to ask them what's going on. And you can't just say, hey, can you tell me why this happens? Or like, people will get impatient. They have a busy job as well. And they sort of need to have assumption. You have to sort of try 80% effort, try to understand, hey, what's the scenario here? And when you ask them, they will say, is this the reason? You don't say like, what is the reason? But you'll tell them, I think this might be the reason. Can you confirm that? And then they will be impressed that, oh, you clearly have a clue. And you start to build trust over time, because working with IT is not easy. They will ignore you because they are usually very busy. And if you don't get some input from them, you will waste two weeks, trying to figure things out. But if you become buddies with them, they're much more willing to help you, right? So relationship building is also very important. So that's why when companies hire early stage, small boutique companies hiring data engineers or data scientists, the business communication skill is very important, right? And of course, you need to be skilled, but you need to sort of need to learn things really fast, and you cannot be the shy person or very quiet when you're in a project meeting. Like sometimes you have to be very comfortable talking with people, and just to build that relationship and build the trust. And that's important. Imagine you're dealing also with 8 different departments, right? And yeah. So like, I guess that's why with smaller companies, right? In interviews, you tend to talk with the senior people, like sometimes the founder, co-founder, or, VP. So the communication is definitely the key. Yeah. Okay. Well, I think that's it. We're at the end of this presentation, and I hope you guys find this career guide useful. Definitely go check it out and follow us on YouTube. And yeah, we have some other events going on next week as well. Um, we'll post that, and I hope you guys stay in touch. And yeah, have a great weekend. I'll talk to you guys soon.